about microcanonical ensemble. So what are the characteristics of microcanonical? So number of particles is constant and the total energy must be constant and any other constraint as defined. Just now I was talking about the constraint of volume, that is the partition between the two and the microcanonical ensemble you can change. So that was what I was wanted to tell you in this diagram. So here I have shown the volume as constant here. So I will impose another condition that the volume is variable, but provided the number of particles should be constant. Let us say 1 is having 100 particles, 2 is having 100 particles. So that 100 number should be maintained constant, provided I am putting another constraint, that is volume is a variable. That means this partition is no longer constant, it is moving. If pressure becomes more in one, what happens? The particles in one will push the membrane or partition, whatever it is here, it will push towards 2, such that volume of 1 will increase, volume of 2 will decrease, provided what happens? It remains 100 only. Here also in 1, number of particles is 100, in 2, number of particles is 100. That is, number is maintained constant. But energy they can exchange. So because pressure is more here means what? Their energy is more. So naturally energy will flow from 1 to 2. So exchange of energy is allowed, whereas exchange of particles is not allowed. So that is the meaning of microcanonical ensemble. If they are exchanging energy with respect to each other, then what about the total energy? The total energy of the whole system, it should remain constant. So if one will have fall of energy, another will have gain of energy, such that total energy of the whole system is constant. Okay, so that is the meaning of the microcanonical ensemble definition. So these are all fundamental definitions. So before only I should have told, but directly I started the class. So these are grand canonical ensemble. This is another type of ensemble. So they are completely open system. That means there is no restriction for energy, no restriction for the particles. Any number can enter in, any number can go outside also. Okay. So they can exchange energy also. So there is no restriction, open systems there. They are called as grand canonical ensemble. So how many ensembles we have studied? Canonical ensemble, that microcanonical ensemble, then grand canonical ensemble. These are the 3 types of ensembles which we come across in day-to-day life. Okay. So next is definitely, yes.
Ma'am, Lakshmi is waiting, ma'am.
Okay. 1 minute, I'll put her in. Admitted, no? So next is definition of probability. So probability is the what is that? Possible outcome of a given statistical event. So it is actually there are some variables that especially when the count rate is very high. So at that time we cannot go on counting everything. For example, this corona period. So how many are infected at every second? Is it possible to count it? Not possible. One day we can count. So you can make a graph and you can plot a graph and you can predict. Or 1 year you can do, or 3 months you can do. But every second, how many corona patients are there? Is it possible to predict or count it? It is not possible. It is a very rate is also very high. And how many are cured per second also, it is very difficult to count, isn't it? So in such events, the statistics is used. So whenever any event output you want to know, it is explained or defined in terms of probability. So probably this might have happened. Probably this will not happen. So they have predicted. So by end of another 2 months, corona will end completely. They have predicted it. How did they predict? This is probability theory. That is statistics. So they have seen how many are increasing, how many are decreasing. From that, they have got some statistical fitting for the data. So from that, they have predicted that this is the probability of event. So event may be curing or increasing or decreasing. So the event, how you want to define that event. So that defines the probability of that event. So you can define any event. For example, the number of girl child in this country. So every year, every month you can do it, but every second it is not possible to do it. It is very difficult, isn't it? So like that, if some examples are given here. So for example, tossing of the coin. So you have done, all of you, you did statistics experiment in the class, isn't it? You were given, what was given? Marble was given, I think, for you people in the class. And I told you people to find out the diameter there. And you try to calculate the probability. And you fitted a graph and you got so many variables, like standard deviations, etc., error analysis, all you did. So there is another example, tossing of coins to determine how many times head appears. Let us say one coin is given to you. Go on tossing the coin 100 times, 200 times. How many times head appears? How many times tail appears? So you count it. So that is called statistical study of the tossing. Okay. The whole world citizen count with bachelor's degree to find the literacy count. How many are literate? How many are illiterate? That also forms one of the statistical study. Okay. An area and state count in a country with temperature 300 degrees Kelvin. So you count throughout the world how many cities have got an ambient temperature of 300 degrees Kelvin. Let us say morning, around 10 o'clock. Okay. So that is again a statistical study, that is, you can plot it. So different country, latitude, longitude wise, you can make a plotting and you can study. So which is our favorable country or state or area, you can find out from the graph. Okay. So these are the some of the fundamental definitions. Some more precise definition of probability can be given like this. So let's see the event, that is event occurring. For example, just now I told how many times head appears, how many times tail appears. Let us say event count, that is head, it has appeared 50 times. So I have conducted total 100 number of trials. Okay. Then what is the event? Probability of the event? 50 by 100, that is 0.5 is the probability. So first class itself I told probability can be 0 or 1. Okay. It varies between that value. Or you can define in terms of percentage also. That's also allowed. Okay. So in another way, probability is also counted like this. That is summation of event counts divided by total number of trials. This is for a single event. First formula, multiple events. So here some examples I have given. Event is occurring 67 times out of 100 trials. So the probability is 0.67. So it is 67%. Okay. So let us say there are 3 events are occurring. So events I will call A, B, C. One is 43, another is 20, another is 37. So totally I have conducted 100 trials. So what is the collective probability of the whole, whole event? The collective probability is the sum of the individual probabilities divided by 100. Or you can also call this is 43%, 20%, 37%. That way also you can define it. Okay. So the plotting of P versus N, it resembles a Gaussian curve. It's a Gaussian distribution. So event count is very large. At the beginning itself, I told first class, when events are more, binomial distribution tends to Gaussian distribution. So that's why I will call this as a Gaussian distribution. So what you have to remember, P can be 0, yes or no. If it is yes, 1. If it is no, it is 0. Event is occurring, yes. Probability is 1. Event not occurring, no. Probability is 0. In terms of percentage, it is 0 or it is 100%. So these are the quick points to remember. Okay. So here I will stop the class. So today I have given you important some basic definitions regarding probability and how to calculate the probability, joint probability, etc. So next class, I will go into details of different types of ensemble, that is microcanonical ensemble, grand canonical ensemble, etc. Their detailed properties and related mathematical derivations. Okay. So today's one question is completed, that is Fermi-Dirac distribution, number count, as well as the energy equation derivation. I have given it as homework. You complete those two tasks. Next class, that is tomorrow, I'll see those two. Then I'll go to the next class. You have to complete it. So remaining slides are all basic that is required for tomorrow's class. So you go through it. I'll share this video today by evening. So you read it, come prepared for my next class. Okay. So any doubt is there, you can ask me. Hello. Hello.
Yes, ma'am.
Any doubt?
No, ma'am.
So I'll stop the class now. Okay. We'll meet tomorrow around 4 o'clock. I'll share it in the WhatsApp. Fine.
Okay, ma'am. Yes, ma'am.
Thank you.
Ma'am, tomorrow we have class at 4 o'clock, ma'am.
Who is taking?
Lakshmi, ma'am.
Okay.
And next
So 5 o'clock shall I take? 5 to 6.
Yeah, ma'am.
Because
Okay,
already
ma'am.
classes started very late. 5 to 6 I'll take. Fine.
yes.
Okay, ma'am.
Okay, ma'am.
Okay. Gautam, share the attendance.
Yeah, ma'am, I took it.
Okay. Now you send second session, you send the attendance.